Unfortunately, I'm not that old. Good afternoon, everyone. My name is Andrew, and I'm up here today as the most junior of the Holsworth beneficiaries. So I thought it would be appropriate that I start by showing everybody this. I managed to salvage this from my grade 6 yearbook, and as you can see, when asked to list my greatest ambition, I wrote down biologist. So I hope you'll appreciate what an honour it is for me to stand here today as a biologist to tell you all about my research. And I'd like to start by playing you this very pleasant sound. That is a songbird. A fairy wren singing his little heart out in order to attract a mate. But that singing didn't happen just like that. In fact, that bird put just as much effort into learning to sing as you did when you learned to talk. This is called vocal learning. But not all birds are created equal. When it comes to learning how to sing, some are simply better at it than others. And we still don't really know why. There is one theory, according to the developmental stress hypothesis: nutritional deficiencies in early development can affect vocal learning. But is this the whole story? I didn't think so, and it got me thinking, what else might affect vocal learning? Could a bird's personality determine how good a vocal learner it is? I see perhaps a few of you looking a little incredulous. Surely animals don't have personality, but they do. Anybody who's ever owned a dog or a cat knows that they don't behave just like every other dog or cat. They have their own temperament. They respond to situations in their own unique way. And the same is true for most wild animals. And because animals with different personalities tend to choose different learning strategies, this could affect how well they learn to vocalize. Now, to put this idea to the test, I used the superb fairy wren, a species which represents the pinnacle of evolution on planet Earth. I didn't want to oversell that. Now, one of the species' many quirks is that they are cooperative breeders. So a typical social group consists of a single breeding pair, as well as a bunch of male offspring who hang around to help raise their younger siblings. But in this happy family portrait, there's also an element of intrigue. We see fairy wrens and notorious philanderers, and up to 3/4 of all offspring will be the result of a mating outside the social pair. Now at Serendip Sanctuary, we have a study population of over 400 superb fairy wrens, and they're all colour banded so that we can keep tabs on who's who. For example, this particularly vibrant male has the colour bands R, S, and A. That's red, silver, black, and azure. And he's the dominant male in his territory. Now to run this experiment, first I needed to make sure that birds were actually learning their calls. So what we did is we found pairs of wild nests, and then we switched the eggs around. This is called a cross-fostering experiment. And this way, offspring are being raised not by their genetic parents, but by unrelated foster parents. Now, if my theory was correct, I had two main predictions. First, that offspring would sound more similar to their foster parents, and this would prove that they were learning from them. And second, that how much more similar they sounded would be related to their own personalities. Now, one of the most common ways of measuring personalities, or one aspect of personality, is what's called a novel environment test. And that's when you release an animal into an unfamiliar room, like this one here, just to monitor its exploration behavior. And fairy wrens really do respond in their own unique way. For example, some birds like this one here, they don't do very much at all. They just stay on a single perch and show no real interest in exploring their surroundings. We would call these slow explorers. Other birds, like this next one, do the exact opposite. They charge around, boldly exploring every little crevice. We would call these fast explorers. Now the interesting thing about these personality assays is that they're repeatable. So if you test the same bird more than once, it will tend to do something similar each time. So I could test for vocal learning. I also recorded each bird's vocalizations. And this is what I was interested in. It's called a contact call, and fairy wrens use it to keep in touch with each other while they're out foraging. Now, if you listen to these two calls from two different birds, you may not notice the subtle difference between them. But by plotting the calls as a spectrogram, that's frequency or pitch over time, you can see that there's plenty of room for individuality. Now I compared contact calls in two different ways. First, I used this process called spectral cross-correlation, And what this does is it takes two spectrograms like these, and then it slides them past each other. The computer then spits out an R value, which represents the amount of overlap between the two calls. And the closer that value is to 1, the more similar the calls are. Second, I measured specific bioacoustic parameters. So things like the number of elements that make up a call, call duration, and also peak frequency, which is the pitch of the call at the point where it's loudest. And so with these methods, we dove into many, many months of field work. Day after day, we braved the elements, and occasionally the wildlife, in order to collect as many data as possible. In total, we ran personality assays for 512 different birds, and I recorded contact calls for 456 of those. And straight off the bat, we found some interesting things. Fairy wren contact calls do seem to be individually distinctive. And they also vary with sex. As we see in this graph here, males on the left side give calls that are significantly deeper, lower in frequency. But were the birds actually learning these calls? To test this, the first of my predictions, I compared the calls of my cross-fostered offspring with those of their genetic fathers on the left and their foster fathers on the right. Now remember, the higher the R value, the more similar their calls are. And as we can see here, offspring sounded more similar to their foster fathers. And this is consistent with our prediction that fairy wrens learn their contact calls. Now, this is actually quite an exciting result because it goes against conventional wisdom. Simple calls like these are traditionally considered innate rather than learned. And it's only in the last 10 to 15 years that we've started to overturn this assumption. In fairy wrens in particular, there's a very good reason why it might be beneficial to learn your contact calls. And that goes back to the extra pair paternity that I talked about earlier. If you're a superb fairy wren chick, like this guy on the left, you're often entirely unrelated to your social father. But being able to call like him could promote group cohesion and enhance your own survival prospects. So spurred on by this positive result, I moved on to my second prediction. Is it possible that birds of some personality types are learning their calls, but others aren't? If that were the case, we might expect a relationship a bit like this, in which birds sound more similar to their foster parents as personality changes. And this is exactly what we found. As we can see here, slow exploring birds sounded more similar to their foster fathers, whereas fast exploring birds on the right sounded much more similar to their genetic fathers. And this is actually quite a significant correlation here. So why should this be the case? This actually ties in really well with what we already know about personality. In problem-solving experiments, for example, slow exploring animals tend to be more responsive to things in their environments. So it's possible that slow exploring fairy wrens are simply paying more attention to their social fathers, and therefore they're able to copy their father's calls more accurately. Fast exploring birds, on the other hand, might be less attentive to their surroundings and therefore retain more of their inherited call structures. An extra possibility that I haven't tested is that both personality and vocal learning are being connected by the same common variable, developmental stress. And this would potentially tie in with what I talked about earlier, the developmental stress hypothesis. I could test this by monitoring feeding rates during infancy, or even supplementing them to see how this affects both personality and vocal learning. And that, ladies and gentlemen, is where my master's research comes to an end, for now at least. Through cross-fostering and vocal comparisons, I found evidence not only that contact calls are learned in the superb fairy wren, but also that personality may play a role in this learning. Songbird vocal learning is a complex process, one that ornithologists are still struggling to wrap their heads around. Hopefully, with future research, we can delve in a little deeper and find out exactly how these little bird brains are doing it. Thank you very much. And thank you, of course, to everyone who made my research possible over the past 2 years.
Okay, while we have Andrew here, I'd like to call upon Professor David Gardner to make a special